This is a demonstration of how to code a two-dimensional array. It's assumed that you've already been coding with a one-dimensional array and that you've reviewed the lecture notes for two-dimensional arrays. In this demonstration, I'm going to also use nested for loops, which you've seen before, but they come in very, very handy when we have two-dimensional arrays. So that part might be a review as well. In the lecture notes, this is a nice way to visualize a two-dimensional array. It visualizes it as a grid with rows and with columns. With a two-dimensional array, we have two indices. That's the plural of index, two indices. We always start counting at 0, so the first element is at indices 0 and 0. The row comes first and then the column. So this is A sub 0, 1, sub 0, 2, sub 0, 3. We see this a lot in games like Battleship, Connect 4, even Tic-Tac-Toe, and also in Excel. The thing about Excel, though, is Excel uses column first and then row number. So remember, in C++, it's the opposite. We do row first and then column. All right, so if we declare a variable, yes, declare an array, a two-dimensional array, the identifier name is listed here, and we have two indices. The first one is for rows, and this is for columns. So we have 2 rows and 3 columns, and again, it's numbered starting at 0. This would be row 0, row 1, column 0, 1, and 2. So memory has been allocated in contiguous memory locations. That means co-located and consecutively numbered memory locations ready for you to add some data to the array. One way to initialize an array is to simply do it when you declare it. So similar to a one-dimensional array, we're going to use the curly braces. We're going to add the data separated by commas, but because it's a two-dimensional array, you have a one-dimensional array and another one-dimensional array inside the array. I think it's much easier to actually look at it this way. Open and closing braces for the outer, for the number of columns, and then across each row, we've got data elements 1, 2, 3, 4, 5, and 6. All right, so make sure you use the commas to separate each element and the semicolon at the end. All right, and that would have the effect of adding the data 1, 2, 3, 4, 5, 6 to the array, which is called X, using indices 0 and 1 for the column, and 0 and 1 for the row, and 0, 1, and 2 for the column. We'll talk about function arguments in a little bit. In this demonstration, we're going to keep it simple, and we're just going to do it in main. So we've used one-dimensional arrays. Let's do a little review. Let's declare a one-dimensional array, which is really just a list. A 1D array is a list of numbers, and I want to have 5 numbers. So the subscript, I need to have a constant here. It can be a literal constant or a defined constant. But C++ needs to know how much memory to reserve, and that has to be a constant. I can initialize it by adding my data elements separated by commas and a semicolon at the end. So I declared and I initialize my 1D array, all in the same line. All right, now let's do it for a two-dimensional array. Let's do an array of ints, and I'm going to call this number grid. Okay, it's going to look a little bit like a spreadsheet or a table or a matrix, whatever analogy works better for you. Let's do a 3 by 2. That means 3 columns. I keep saying that wrong. 3 rows and 2 columns. First number is for the row. And so the first one is going to be first set of curly braces. There we go. And inside there, I'm going to have 3 rows. So I need to use my curly braces, 1, 2, 3, and a comma after that because that's an element. And then I'll try to line it up so it looks good. Oops, what have I done? My tab jumped it over again. This is a little bit non-standard for C++, but I'm doing it for readability, the indenting. Okay, and I have just done this wrong. I seem to have a mental block about columns and rows, so this is a good lesson learned. I've got 3 rows, 2 columns. I set it up backwards. Don't do that. I set up 2 rows and 3 columns. All right, so let's go fix that. And that's what that red wavy underline is telling me. It's like, hey, wait a minute, too many values. I can only have 2 values in the first row, not 3. So let's fix it. Not a semicolon, a comma. All right, and now my compiler is happy. Okay, 3 rows, 2 columns. 3 rows, 2 columns, and let me just make it really clear. Row 0, we always start counting at 0. Oops. Row 1, row 2, right? So the indices we'll use will rotate, will iterate from 0 to 1 to 2 for our rows and from 0 to 1 for the columns. All right, so I now have 6 elements in my 2-dimensional array. All right, 3 by 2. 3 by 2 is 6. 6 numbers have been stored there. You could, of course, ask the user to input data and use a for loop for that. But I'm going to start with using a for loop to show the array, to display. So as a review, let's do the 1-dimensional array first. And a for loop is the appropriate loop to use with an array because you know exactly how many elements there are. We have a counter control loop for that, the for loop. So while int I, we want to start at 0 as long as it's less than, I'm going to use a literal because that's what I used here. I don't have a constant defined. So for each element in the array, I'm going to iterate from element 0 to element 4. I want to see out I want to see out the data that is stored in the ith in this element. It's first the 0 element, then the this is stored in the 0 element, this is stored in the 1 element, 2, 3, and 4. And let me add, since it's a list, I'll do an end line. So let's do this. All right, so we're going to output the string 1-dimensional array with the space and a new line. And I'm going to output the values each on a new line. Let's build it and run it. And I got 1D array and 1, 2, 3, 4, 5 and press any key to continue. Before we do the 2-dimensional array, let me point out a couple of things. For loops you should be pretty comfortable with this by now. But let me just review that I did not need to surround the body of the loop with the curly braces because it was only one line of code here. But I think it's good style and good design, especially at this point in your programming practice, to include it anyway, because it makes it very obvious that this is what's repeating and nothing else. And then it makes it very clear what's happening afterward. So let's do this. Instead of end line, let's change it to so I want to output the value that's stored in the array, um, a comma, and then a space. And when I'm done with that loop, then I'll move to a new line. All right. So this is the body of the loop. This is outside the loop. All right. So 1D array, 1 comma space, 2 comma space, all the way to the end. And there is a comma at the end. If I wanted to take some time, I would clean that up, but I'm happy with that for now. All right, so now let's do it for a two-dimensional array. We're going to use nested for loops for this. And if you recall, the way nested loops work is the outer loop begins its first iteration. The inner loop completes all of its iterations. And then the outer loop iterates to the next element, and the inner loop completes all of its iterations. So it starts from the outside and works its way to the in. So here, we'll start with int I is 0. This is a 3 by 2. So we want to output the rows first. So if it's less than 3, and we iterate I++. So you can think of this as for each row. For each row in my array, what do I want to do? Well, I want to go through each column in the array. We'll use J for this. I, J, and K are commonly used for indices, especially when it comes to arrays. And I need to add a constant here, either a literal constant or a named constant. But I know that there are two elements. There are two columns. Oh, and I have a typo. I have J here. I need to have J there. All right, for each row, and this is for each column. So for each column, or sorry, for each element in the array, I have the row defined and I have the column defined, and all I want to do is output using my two-part name, the name of the array, and then my brackets to indicate which column and which row. So I indicates the column and J indicates the row. And I'm not going to add any spaces to that. All right, simple, straightforward example of a nested for loop with arrays. I want to show the row first, and then each item in the column, and then iterate up to the next row, each item in the column, and then the third row, each item in the column. So let's see what that looks like. So I got 1D array, 1, 2, 3, 4, 5. I didn't put a header for the 2D array, but I have 1, 2, 3, 4, 5, 6, and I forgot to put an end line. If I want to separate, press any key to continue on a new line, I need to do it outside my loop. If I wanted each of these numbers to appear on a new line, I would have to add cout end line here. But I don't. Or do I? I do. I want it to appear in a grid. All right. So every time I finish a row, I want to add an end line, right? So this is what happens for each row. For each row, I iterate through the numbers in the grid and I move to a new line. And then I get a new row, iterate through the numbers in that row, and then move to a new line. All right, so my 2D array, I've got 1 and 2 in row 0, 3 and 4 in row 1, 5 and 6 in row 2. Okay, and that's all I have for this tutorial. I've got some instructions for you to follow after this. As a quick review, we looked at 2D arrays using nested for loops. This is an example of how you could declare an array, a one-dimensional array, and you could fill the data when you by initializing it when you declare it. And this is how you would initialize a two-dimensional array. You declare your your two subscripts, your rows and your columns. You input the data here, and if you want to output, you want to use for loops. So for loops are going to be used whenever you want to, if you want to fill the array from the keyboard, or if you want to fill the array from a file. For loops will be used if you want to process the array. Maybe you want to get totals and averages, or find the high and find the low. You're going to want to use for loops for that. And then for loops are useful again when you want to display and you want to show. All right, that's all I have for this one.